So in this video, we're going to discuss two additional tools that we can use to measure pressure. The first is a manometer. So there's a few different varieties of manometers. The most basic one is a U-tube manometer, which is shown on the top right here. So the U-tube manometer has measures two pressures, P1 and P2, and the difference in pressure causes there to be a height difference in the measuring fluid, gamma m. So using that ratio between the pressures in both tubes, we can relate the pressures to one another and determine the pressure difference across P1 and P2. All right. So we're measuring a differential pressure here, not an absolute pressure relative to atmosphere. So, um, so if we do a pressure balance, right here, what we end up getting is the difference in pressure between point 1 and P2 is equal to gamma m, the difference between um, uh, gamma m and gamma times the height. Okay, so the difference in the density of the fluid and the fluids that we're measuring in the fluid that we're using to measure and the fluid or the pressure the the medium of the fluid's pressure interested in measuring. So if we're using water and air, they would have very different gamma m and gamma. But if we're using two liquids, they might have similar specific weights. So that will affect the sensitivity of our manometer. Okay. Um, so the measuring fluid that you use is important depending on the change in pressure you're trying to measure. A micro manometer is shown on the right, and that's used to measure very small differences in pressure. So again, we are trying to measure the pressure differences between 2 points, P1 and P2. So typically we have one known pressure, all right, and we can adjust the pressure. If we adjust the position of one of the pressures using a micrometer, we can measure the change in height, and we can correlate that change back to the pressure. Right? And then the last instrument is the inclined tube manometer. So the inclined tube manometer works the same principle as the U-tube manometer, except the change in sensitivity is increased by placing one of the tubes at an angle. So basically, the change in height we can relate to L sine of theta. All right. So, all right, and then we use again just the change in pressure here is just a function of the gamma m and the uh, and the specific weight of the fluid that we're trying to measure. So this would be gamma. Right. So, and then the last type of pressure measurement is used for when we typically have very large pressures. So something like 70 megapascals, which is like 10k psi, so very large pressures. That's called a deadweight tester. So what a deadweight tester basically uses the definition of pressure, which basically says the force, we take the total force that we're applying divided by the area, and then we have an error constant uh, uh, that we take to account. Right? So sorry, that should be a subscript, that like E. So this is just A of E. All right. Um, all right. So for most situations we can ignore the error terms, but errors we can account for errors due to gravity effects due to altitude and latitude, as well as buoyancy effects. So you can adjust the pressure reading to account for those errors using the E1 term we talked about earlier. We were talking about barometers, and the E2 term deals with the buoyancy effect here. So there can be additional errors as well due to shear forces, between the piston cylinder, an elastic deformation of the piston, but basically you have pressure going in that causes the the applied force here to move up and down, and once it's adjusted, you can then determine what the equivalent pressure would be. Or basically, if the piston does not move anymore, we know that it's balanced and the applied force matches the reference pressure. Okay? So, all right. So that concludes our discussion on different instruments used to calibrate pressure transducers, and now we'll talk about actual pressure transducers.